This stuff is not only on the test, this long division, using it to factor. It's not only on your exam, but it's on there multiple times. Because there's so many different connections to be made. Make the connection with the graph, make the connection with that remainder theorem that we talked about briefly. But here we go. So I'm going to tell you in advance. This function is groupable, but we're not going to do it that way, okay? Because I'm going to start with a basic one on the exam. I don't think they'll give you one that's groupable, but they want you to find all the zeros. And assuming it's not factorable by hand, by our traditional methods, they have to give you something to start with. Well, I guess they don't have to. If they didn't, we could type it into our calculator and steal some roots. But they're telling us that it is divisible by x plus 1. So if they're telling us that, we're going to start by doing long division and dividing out x plus 1. So go ahead go through that on your own, and then look up only to check your answer so that this is a little extra practice for you. Okay, they have to give you a root or a factor to get you kick-started here. And that's what they did by giving us the x plus 1. Are there any questions on the long division here? I know they gave me a perfect factor because I had a remainder of 0. And that's what they have to give you. They have to give you a perfect root or a perfect factor. So how do I use this result to find all of the zeros? Well, if I'm looking for the zeros, I'm looking for where this equals 0. And right now, I was just able, by doing long division, I was able to factor this into x plus 1 times what, Aiden? No. This times what will replace this? Someone help him out. Isaiah. Right. The quotient. The quotient times the divisor gives you the original. So times x squared minus 3x plus 2. So I just factored that. And I need to continue factoring. And here's what I'm talking about. It started as a third degree polynomial. I divided out one linear factor with a degree of 1, which knocked it down to a quadratic. And now anything that's a quadratic I can do by hand, either by splitting the middle term or guessing and checking. So I'm going to guess and check on this trinomial because it's pretty basic numbers. It has to be x and x. It has to be 2 and 1. It's a positive 2, so they have to be the same sign twice, negative and negative, since the middle has to be negative 3x. So use the results to find all the zeros. Well, I found all the factors. So if I'm answering the question, all the zeros are negative 1, positive 2, and positive 1. Those are all the zeros, all the roots, all the solutions, however you want, however they may phrase it. Does that make sense? Okay? Now, again, like I said, this, if we had grouped this, we would have gotten the same answers, I think. Well, let's see. You don't have to do this, but if I had grouped it, what would I take out of the first group? X squared, left with x minus 2. What would I take out of the second group? This was a group. What would I factor out as my GCF? Negative 1, right? Because it starts with a negative. and I'd have x minus 2. See how grouping worked? So my two factors would be x minus 2 and x squared minus 1. Still a linear and a quadratic. Different than the linear and the quadratic that long division led me to, though, right? But why is it the same? Because x squared minus 1 is the difference of perfect squares. We still have the x minus 2, but the x squared minus 1 is x plus 1, x minus 1. Okay? If grouping works, it's still definitely the fastest way. But if they want to test your long division and your understanding of how long division factors for you, they're not going to give you one that's groupable, I can promise. Okay? Any questions? But I wanted to start with one that we could see both ways. All right. Another question. And I'm covering up the second half for a reason. It just says solve the equation. Now again, polynomial equations, the only way you know how to solve them up until today is by getting them equal to 0, factoring, teeing it up. If it's not factorable, though, and this one grouping is not going to work, you have to do long division. Now, you could just type it into your calculator, steal a root off of there, and divide out that factor. Or what's more prominent is they're going to tell you something that's going to allow you to go through this. They're telling you that 2 is a 0 of this function. Now, look at this function and look at the equation you're solving. They're the same thing, right? This is written as a function. This is written as an equation. But 2 is a 0 of this. If 2 is a 0, then what's the factor? X minus 2. So if 2 is a 0, then x minus 2 is the factor. That's what we're going to long division out. And because it's a factor, we know we should be getting a remainder of 0. So 2x squared. Again, do this on your own and check up to the board just for confirmation, so we're still practicing our long division. Okay, so we got a remainder of 0. X minus 2 is a factor. Aiden, I want you to try again. How did we just successfully factor this into what times what? Good. And then once we have that quadratic, we can solve the rest of it by ourselves. Now, hopefully that quadratic is factorable, is it? 2x and x. Has to be 1 and 1. Then we got to play with signs a little bit, because 1 is a plus, 1 is a minus. I'm going to keep that x minus 2 out in front also. Since my middle term is negative x, I want it to be a negative 2x, so I'll put my minus with this one. Plus. And that further factors my quadratic. And I can tee everything up. So what are my solutions since I was solving an equation? Oh, Micah, what are my solutions? Two, 1, and negative 1/2. We would tee this up. So if we can't see that, just take the time to set it equal to 0, subtract your 1 from both sides, and divide by 2. So negative 1/2. So we have solutions. Back to the quadratic thing, and what Nate had said earlier, if this quadratic wasn't factorable further, so what? Just do the quadratic formula with it, and you'd get the same answers. Okay? And even if you hate factoring quadratics, so what? Do the quadratic formula with it. You can still tee up a quadratic if it's not factorable. Okay? On exercise 3, same type, but a little bit trickier because what do we say about these roots? If this is the root, if the root is negative 3/2, what's the factor? Who can tell me the factor? Maggie? 2x plus 3. So she obviously can do that in her head. Most of us cannot, which is fine. We just need to slowly multiply by 2 on both sides, add the 3 over, and there's your factor. So same exact type of question, we're just going to factor out the 2x plus 3, and we're not actually going to go through this problem because other than that it's going to be exactly the same. But I just wanted to review how to get a fractional root to an appropriate factor. Okay, flip over. So here's one. They don't tell us what a root is. They don't tell us what a factor is to get us started with long division, but they show us a picture. Yes? Remember what this scale on the bottom means? It means the x is showing us from 0 to 4, counting by ones. So 1, 2, 3, 4. What's our root? 2. Our root is 2. So what's our factor that's going to divide out of this, Evan? If 2 is the root, what's the factor? X minus 2. Very good. So we would do long division and divide out x minus 2. We're not going to do it, but do we get the concept? Yes? Okay. Here's one. They're going to give us information via a table. Where's our solution? Solutions are the same as which intercept? X-intercept. X-intercepts are when what equals 0? Y. So look at your y values. We find the 0. What's the coordinate? 1. If 1 is a root, what's the factor? X minus 1. And we would do the long division with that. You can see all the different ways this can be presented. It's a little tricky. But hopefully it's making sense. And then exercise 6 is just use a graphing calculator to find your starting point. So kind of like on your homework quiz last night, just type this in and just find one x-intercept to get you started. Now you can trace it, and there's 3 of them. Half the class could start at -2. Some more people could start it with 1. And some more people, it looks like 1, 2, 3, 4, could start at 5. Whichever root you decide to start with, factor it out. You'll all get different quadratics, but when you all factor your quadratics, you will all end up with the same 3 linear factors. And they're clearly going to be x plus 2, x minus 1, and x minus 5. But if they want you to show your work algebraically, you just steal one of those to start with and show your long division and then factoring by hand from that point forward. So, of course, with a skill that was somewhat enjoyable, there's a little bit of, now we have to use it and understand what it's good for.